Hello, Miss Ari, are you alright?
Yes.
Okay, so today we are talking about the longest.
Mm-hmm.
0, sublist, sum. So what's sublist?
The continuous thing.
The continuous thing. Okay, so 1, 2, 3. How many sublists?
Wait.
Can you give me an example of the sublist?
1, 2, 3. 1, 2, 2, 3. 1, 2, 3.
Is 1, 3 a sublist?
No.
But it's a subsequent, right? You got it? Yeah, it's not continuous. We have sublist and continuous. Okay. So given now today's task is simple. Given a list which is only one containing 1 and minus 1. Okay, 1 and minus 1. We want to find out the longest sublist which has the sum 0. So in this case, what's the longest sublist? 1 minus 1, 1 minus 1 minus 1. Come on, it's very obvious.
All of it.
All of it, yeah, added together. How about this? If these, and you need to tell me it's 6, yeah? Tell me it's 6.
Well, what?
And how about it only has 1? What's the longest sublist?
0.
0, because you can't find it. There's no minus 1. It can't be 0. That's good boy. Good job. Okay, so now, what's your approach? We want to find the length of longest. What's your approach?
Brute forcing.
How do we brute forcing? How do we brute force? How do we brute force?
1.
Brute force, yes, we're done. Brute force. Brute force. So we want to check the sublist. Can we brute force all the sublists and then check the sum, right? Alright? Okay, so let's do this. Define longest sublist lambs. At the beginning, we want to have this answer. Answer equals what? What's the answer?
0.
N will be equals to the length, right? Length of lambda. Okay, so for, let's do the left will be I, right? I in range. Range what? Range what?
N.
And yeah, I will be from left to yeah, and then when I is determined, we want to start with J for J in range what? Range what? Come on, I is here. J will be from here to the end, right? So will be what?
I to N.
To N, where that? Okay, so now I and J is the index of the sublist from the leftmost and the rightmost. So how do we calculate the sum? What's the sublist? The sublist with nums. Nums I to what?
J.
Do we need to plus 1, yeah?
Yeah.
Plus 1. So we can use the sum function, right? How do we calculate sum? If sum equal 0, and we want to update the answer. Answer equals max what?
Answer.
And what's the length between I to J? What's the length between, how many integers between I to J? 2 to 4, how many integers?
3.
How do you get a 3?
Just count.
200 to 331, how many integers? Inclusive. You count?
Okay.
How many integers? How many integers between I to J if both are inclusive?
J minus I plus 1.
Yeah, 4 minus 2 plus 1. Okay, so here, J minus I plus 1. And then return.
Answer.
What's the time complexity? Oh, what?
Cubic.
Oh, in cubic. Well done, look. For one n, in order to iterate this n loop, we need to iterate another n loops. But here, look, there's no n, on, there's no loop here. Why is on cubic? Come on, can you tell me why? So, sums, yeah, you need to, this sum actually will need to count already. Okay, so look, we can improve this brute forcing. Yeah, we still brute forcing the pairs, but instead of every time we calculate the sum of the sublist from the start. We can do some, we can accumulate the answer. Why is that? Look, 1, 2, 3, 4. We are now computing the sublist sum of these. Yeah, which is what, Eric?
Yeah.
Which is what? Which is 3, right?
Yeah.
And now the J, we move to the next one. Eric, look.
Yeah.
J, we move the next one to here. So what's the sublist sum of this new array? 1, 2, 3. 6, yeah?
6.
How do you get a 6? How do you get a 6?
Well,
You already know this is 3, yeah?
yeah.
It's 3 plus 3, right?
Yeah.
We use the 3. You are not doing this with 1 plus 2 plus 3 again. You're not doing this again, right? The previous method is slow because you're recalculating this bit again. But we don't need to recalculate this again because here we already know it's 3. So we add a new number to the sublist. We just accumulate the answer. So here we put the s equals 0, and what should I do here? What should I do here? What should I do here? S plus equals what? And then if s equals 0, s plus equals what? S plus equals what? Nums what? Nums what? Come on. J is here. Every time I have J moves to new numbers, I added it. Yeah. What's the time complexity for this one? Louder.
Square.
O n square. Well done. So which one is better now?
N square.
Yeah, we reduce, we improve it, yeah. Okay, so this is O n cubic, O n square. These two are both brute forcing because we are trying every possible sublist. Yeah. We first determine the left, and then we start the right. Yeah, and then we compute the sum of these sublists. Do you still remember the prefix sum? Prefix sum? Prefix sum. Look, Eric, look. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the sum between 3 to 6?
18.
18, you just calculate, yeah? Yeah.
I didn't.
3 plus 4 plus 5 plus 6, yeah? This is one way, which is O.
But I didn't.
Okay, and then how do you get it?
I did
You did what?
1 to 6 flip.
Ah, okay, so that's what I'm going to take. What's the time complexity if you're calculating this brute forcing? Just try, adding the numbers from the left to from a given range. Come on. What's the time complexity? If I give you a range and I want you to calculate the sum of this range. What's the time complexity?
N.
Oh, n, yeah. Because in the worst case, it will be n numbers. Yeah, you need to do it again and again. But we can turn this into the prefix sum. Remember this accumulate. Yeah, accumulate function. This is a, for example, and then accumulate a. This accumulate a. Accumulate. Yeah. What's accumulate mean? Accumulate, adding together, accumulate, yeah, putting together. So this accumulate A will be what? Will be 1. 1 plus 2, 3. 1 plus 2 plus 3.
6.
10. Yeah.
20,
And then 15, adding together. 21. 21 add 7.
28.
36. 45. The sum of these 4. Is it the sum between how many numbers? These 4 numbers, yeah? The sum of these 4 numbers.
Yes.
Is it the same as the sum of these 6 numbers? Yeah? Yeah? This 21 is the first 6 numbers. And then minus the sum of the first 2 numbers. Right? Got it? Yeah? The first 6 numbers is 21. The first 2 numbers is 3. So what's that? 18, right? You say 18. 3 plus 4, 7. 7 plus 5, 12. 12 plus 6, 18. What's the time complexity is given. The accumulate this prefix sum is given.
I want.
Oh, one, yeah, because we just need to look at the tables, look at the prefix sum, pick this number, subtract, and we got the answer. This is better, right? This is faster, right? Yeah, because we are reusing the numbers, reusing the arrays, right? The numbers, the sum we have calculated, we have known, right? Okay, so now based on this prefix sum, we can actually solve this problem in ON, right? So how do we solve this? We can actually going through these numbers, and then if the sum, we remember the prefix sum in a dictionary, right? Yeah, we remember the prefix sum in the dictionary, and if it's already appear, then we can subtract the distance and then store the maximum. And if not, then we put it in the hash table. Okay, so let's do this. Define. Let's call it full. Okay.
What?
You know the computer full and bar. Yeah, full bar. In case you don't know how to rename your functions, your variable, you can always give these two names. Yeah, full and bar is easy. It's easy to write. It's easy to pronounce, right? Yeah. Full and bar. Okay. Okay. So now we put it in the addition the prefix sum. Let's say prefix equal. At the beginning, we put it in a default dictionary. Yeah. No, in a dictionary. Okay. But I'm going to put a 0 here and -1. I'll show you why I put a 0 to -1. So look, for the answer would be 0, right? The answer would be 0. Okay, come on, listen to me. For value in enumerate, yeah? Let's do it. What's enumerate, remember? Enumerate, how do you spell enumerate? How do you spell enumerate? E-N-U-M-U-R-A-T-E. Okay, so let's do this. N. Okay, enumerate. I spell it wrong. Correct. E-N-U-M-U-R-A-T. Enumerate. Nouns. What's enumerate? Let's take a quick review. Eric.
Yeah.
If this Eric, okay, E-R-I-C, yeah.
Yeah.
This is a string. S equals ERIC. For I in S, print I. What do you think what we get? For S is a string, ERIC. For I in S, print I. What do you think what we get? What do we get? Eric is.
Eric.
You just print each letter, yeah? So you print E and one line R, I, C, you print something like that. How about if I say print for I, J in enumerate S and print I, J. What do you think what we get? What do you think what we get?
I don't know.
Enumerate, remember we talked about enumerate. This is the index, this is the value. So look, the index 0, E, 1, R. And what's this?
Wait, that's I.
Okay, what R? 1 R. And what's this?
2 I. 3.
Exactly. Okay, so look here. I will be from 0, incrementing, yeah? And N will be actual value, yeah? So now we have this, let's have this current answer, okay? Current equals 0. Current plus equals ION. Current plus equal ION, right? We want to plus the sum. So we plus what, right? We plus N, right? And now we have this is the prefix sum of the first, first few numbers. And then we just do, if this current equal 0, what does it mean? Alright,
Yes.
you need to follow that. If the current equals 0,
Column.
yeah, I know. What does it mean? It means that currently, from the start to the current position, look at that. From the beginning, look at this. If this array is 1 minus 1, 1 minus 1, 1 minus 1, okay? If at this point, we have this sum 1 minus 1 0, 1 plus minus 1 0, right? If this current equals 0, what does it mean? It means the longest sublist sum is 0 is from which place? From the start, right? Yeah? So now we could just do this answer will be equals I plus 1, right? Alright, look. Yeah? Then we can do this if current in P. If current in P. If current in P, what do we do? If current in P, so P current stores the previous sublist sum, sublist sum of current, the index, right? So the answer will be maximum of answer. What? Current index is I, right? Right, Eric? So why this is working? Look, if there are two sublist sum, if the two previous sum is the same, now what does it mean? If two previous sum is the same, then the length. If I draw it, look this way. Okay, this from the beginning to here, this is 100. This means 0 here, right? And then another later I found out this is also 0. The sum of maybe I put it somewhere. This is the sum of from at the beginning to this point I is 100. And then I found out later J here. The beginning from the beginning to J, yeah, J is bigger than I, is also 100. What does it mean? The sum between the beginning
It can't be bigger.
No. Look, the sum of this range, the numbers in this range is 100, and the sum of this 100, this range is also 100. What does it mean? Can you tell me what does it mean?
This one needs to be more here.
More? What do you mean more?
Because you know that I don't know.
No. Because this array could be 1 and minus 1. It could be. So what I'm saying is that the sum, the prefix sum, yeah, the sum between 0 to index I is 100. Yeah, let's say 100. And the sum between 0 to j is also 100.
I and j are the same.
No, you can't. I and j is bigger than I. What does it mean?
It means that
It means
you can't start from 0.
no, it can be start from 0. So what happened here?
Oh,
What happened here? What's the sum here?
0.
Good point, yeah. Because the sum over here is 0. That's why added here 0.
Oh yeah.
Oh yeah. So this is the length of the 0 sublist, yeah? Got it?
Yes.
So we just need to calculate the j minus I, yeah? Got it?
Yes.
That's right, yeah. Okay, so look, I here current is I minus P current. Okay. And then else what? Else if the current is not in P, what do we do? Current is not in P, then P current equals what? Equals what? Come on, tell me. What we need to store the index, right? Which one is index? I. That's it. So you see, if current equal, and here we don't need to put it here. Look, this is very tricky. If current equals 0, because if current is 0, answer will be I plus 1. Why is that? Because this current is the sum between the beginning, yeah, between the beginning. So if it's a 0, you can't find any longer 0 sublist sum than from the beginning to current, right? Right? It's always bigger, right? Got it? Look, you have a number, yeah? You have a number. You're going to the beginning. This is current sum. Current will add the sum here, current sum here, get the other sum here. If at this point, look at me. If at this point, this is 0, we found out this is 0. Can you find any sublist sum bigger than this here? You can't, right?
Yes.
Because this is already the largest, the biggest, so I set it to I plus 1, right? Because start with 0, so the length will be I plus 1, right? Got it. And if we can remove this, and instead of here, I can put a 0, key 0, sublist sum 0, I could minus 1. Yeah? Got it? Okay, so this will be simplified, yeah? This is one way, so this is, what's the time complexity? Come on, it should be easy. What's the time complexity? Yeah, we're just going through once. There's nothing here. What's the space complexity? There has to be at some cost, right? how do we trade the time for what? How do we achieve ON? With the help of what? Which data structure? ON, yeah. You see, ON square, ON cubic, it's slow, but it doesn't use any space. The space complexity for these two is O1, yeah, constant. But now we're using ON space. We're using the space to trade the time, right? Got it? Okay. Another way, algorithm, I'm not going to talk too much here, okay, is that we can store the prefix. We can store each prefix, and then each prefix we'll store the index of it. So it'll be something like let's try this quickly. Write this, okay? Full nouns, and then look prefix sum. At the beginning, I put a 0 at the beginning. 0 plus list accumulate, right? Remember this accumulate function? We can use this accumulate nums, right? And then now, what do I do with this accumulate? Because I already have this, I also need to put this in a scene, in a hash table. Okay, so scene, let's say scene equals default dictionary. No, but the scene is the prefix, because in the prefix sum, and then the key will be the prefix sum, the value will be the list of index. Yeah, it could be many, as I said. Look, it could be from the 0 to I, it could be sum of 100, and from 0 to j, it will be sum of 100 as well. So the key will be 100, and the value will be the index, which is index array will be ij, right? So default dictionary list integer, right? This is, so the key is the sum, the prefix sum. The value is the index. Okay, so now I just need to go through the prefix for I in prefix in P. Okay, and then I can say scene I let's say I j. Okay, scene j dot append what? Append I, right? I is the index. So for each one, then we can go through the scene. For I in scene, this is a bit complicated. Let's put the answer here. Answer equals maximum. Answer I is the sum, right? And then j will be the scene I will be the list of array, list of the index, and then I want to return the lowest index and the maximum index, the difference. So scene I minus 1 minus scene I 0, right? Right, and then return what? This is the easy part, yeah?
Answer.
Yeah, return the answer. Can you imagine how do we why this will work? Why this will work? Why this will work? So what? As I said, look, I talked about this before. From 0 to here, there will be I. This will be I. 0 to here will be j. Right. So look, if this is the the prefix sum. Alright, look at me. It's scene this. If this is the sum s here, right? And then this is sum also the s, right? So the scene s will be there will be a list of I and j, right? Suppose like that. And the length will be j minus 1, right? Yeah, got it? So I just need to calculate this bit, yeah? You see? This is exactly what I've told before, yeah? So first of all, I calculate, look at me. I calculate the s, the prefix sum, the prefix sum, and I store the same prefix sum, the index of prefix sum to an array. And I go through this thing, the prefix sum, right? This is the sum, and I go through the index, and the length of 0 Sublist sum will be the larger, because this index array is the incrementing, is sorted. So I just have to, what's minus 1? Sin I minus 1, what's this value? Sin I minus 1, where is it? What? Sin S minus 1, which one is I or J? Which one is minus 1? I minus 1, what does it mean? The index minus 1. The which one?
J.
Yeah, the J. And then I0 is this one. Yeah, well, that's what I mean. So it could be any, it could be another one. It could be A, B, C, you know, there will be 4 indexes. So in this case, it will be D minus A, right? This is the largest sublist sum, okay? What's the term complexity for this one? You look at this.
N.
Oh, N. What's the space complexity? Are we using the space? Is this the space? Yeah? O-N, yeah? And the sin.
Yeah.
Sin is the dictionary, okay? Okay, good job. So which one you remember so far?
None of them.
Come on, which one? The proof for thing, yeah?
Mm.
Yeah? Proof for thing, you can write it, yeah?
Well, not really.
Sorry?
I can't write any of them.
Why you can't write it?
I don't remember them. I don't remember all of the stuff.
You don't remember, do you understand?
Well,
Do you understand? Come on. If you understand, that's fine.
fine. I'm fine.
Yeah, okay, that's fine, yeah? You understand? How about let's implement the proof for thing, okay? Got it? Yeah? Proof for thing is better, yeah? Which proof for thing? The ON cubed or ON square? You pick one. I help you. Let's do it together. ON cubed or
I
ON?
don't mind.
ON cubed or ON square?
I don't mind.
Pick one, come on. Pick one. Or ON, come on. Pick one.
I like Owen Square.
ON square, okay. Define. Can you come here? Let's do this, the last one, and we can finish. So at the beginning, we need a variable to store the answer. Answer will be equal to what?
Answer equals
At the beginning.
0.
Yeah, and then n will be equals the length of num.
Yeah.
Okay, then we prove for thing for I in range what?
For I in range numbers.
N, right? And then we need to have this sum for current sum is 0. For j in range, start with the I to what? To the n, right? N. S plus equal what?
S plus equals
Nums what?
IJ.
Nums j. And we need to check if sum equals to 0, right?
Yeah.
And if it's 0, answer equals what?
Answer equals
We want to store the maximum, right?
yeah,
Max what?
next answer.
And then what's the length of current sublist? What's the length? What's I to j? What's the current sublist length? What's the length of this?
J, no, minus I plus 1.
Yeah, okay. And then what are missing at the end?
Return answer.
You see, you know how to do it, right? You see? Yeah?
Yes.
You understand, you remember, yeah? Why you say you can't remember and you don't understand? Huh? Okay, that's it for today.
Bye.
Bye bye.